Hello, everyone. This is Ardon, HL7's Director of Education, welcoming you to this session. My co-host for this session is Andrea Rebeck, Communications Director from HL7. Jean Duto will be moderating the question and answer session. And our speakers are Ardon, Toonstra, and Mirjam Baltus. Mirjam, I believe you have won the toss to bat first.
Yes, correct.
So over to you.
Thank you so much. So hi, welcome. I'm Mirjam, I'm from FHIR, and I'm the FHIR trainer there, or one of the FHIR trainers, because FHIR can provide you with all the training, the tooling and expertise you might need to set your fire alight. With me is Ardon Toonstra. He is going to do the last part of the presentation and the demos because he is one of our profiling experts. So what we are going to do today is, of course, the Let's Build session. I will give you a small introduction, a little bit of background about profiling for those of you who didn't see my introduction to profiling session yesterday. But don't be afraid if you have seen that, it's just a couple of slides, so I will not be talking that much. And then after that, Ardon will take over with a demo and will set you to work with the guided exercises. You do see the link on my slide here, but also in the Q&A, we have posted a short link for you to go to, and then you will be able to participate in the Let's Build. So profiling, why or what can we do with profiling? If you create profiles and extensions, if you create other conformance resources, that helps you describe your requirements, describe your adaptations that are needed for your particular use and context. So it makes it more clear to people that want to connect to your use case or want to work with your particular context to know what they need to do. So, well, there's a couple of things on this slide that you can do with profiling, but of course we are going to make this quick and start you on doing that. Important, of course, is that for profiling, all of those conformance resources that you can create with FHIR can be done in a structured manner. And that is why the FHIR specification has a lot of conformance resource types. Today, we will focus on the structure definition because that will help you create a profile or create an extension. And then we will also see that we can work with a repository to share the work. So it is possible for other people to view what your expectations or your adaptations were. Each conformance resource in FHIR has a canonical URL, and I tried to stress that yesterday during my session as well. You will have to think about that URL, which we call the canonical URL. It's a unique identifier for that particular conformance resource that you create. Also in the FHIR specification, if you look at the FHIR structures, they are all specified in structure definitions, and they take this form here where we can see it's called hl7.org/FHIR structure definition. This is the name of the conformance resource, and then a human readable name. In this case, this is for the patient resource type. You can also, of course, create your own, and what we see most often is that people use that structure definition in the name of the canonical URL when we are going to create profiles and extensions, or use the name of another conformance resource type like a search parameter or operation definition when it's one of those, just to, well, make it more clear whenever you just see that canonical URL, what kind of structure is behind that. So what we are going to do today is get you started on profiling. And that's something that my colleague will tell you. But what can you do with profiling? Well, let's just take this patient resource. We know that there are standard fields in the FHIR specification, and we can do all kinds of nice things with that to adapt that particular structure to our own needs. So we could, for example, say, Okay, we have a national patient identifier here, and we want that to be on that particular resource. Perhaps it's, well, in this case, I did not change the cardinality of the field, so you can see it. Well, I just have identifier 0 to star. So this is a little bit of a more complex constraint. But of course, we can do things with cardinality, limit the names to exactly 1 instead of that 0 to star that's on there. We can also limit choices for data types because, well, sometimes your backend systems are not capable of using a particular choice that is present in the standard FHIR structure. So you can just take out all of the things that are not needed for your particular use case. There's also something called must support. You can indicate with a must support flag that that particular element is important. Even though it might not be set to a mandatory element, you can indicate importance with a flag like that. Or you can even forbid elements to be on the data. Now, I usually take an open approach when profiling, and when you start forbidding things, then you are closing down possibilities. So this is something that you will have to author with care if you want to do that. But sometimes regulations, requirements tell you that some data cannot be sent. So then you have the option in FHIR to profile them out of the structure. And of course, you can also create extensions and then combine them with your profile by adding that extension into your profile. So lots of possibilities. Today, of course, we focus on you as profile author. So that is where we are going to start. We are going to edit profiles, create profiles with the Forge tool, and then we are going to publish them to the simplifier platform so other people can then use them. And of course, you can see the rest of the ecosystem working together with the work that you are going to do today. So that is it for me for now. I will stay on the line, but now it's over to Ardon to tell you more about the tooling.
Yeah, thank you, Mirjam. This is Ardon Toonstra, FHIR consultant at FHIR, and I will take over the screen right now. So, yeah, as Mirjam just showed, FHIR produces all kinds of software to bring FHIR to life, besides being an event company as well. Well, I will introduce the exercises we've prepared for this Let's Build session. Yeah, we will mainly use Forge, but also simplifier to publish our work and see how it's rendered on simplifier. But to start with Forge, it's a graphical editor for mainly profiling in structure definitions and extensions, but it also has support for logical models, search parameters, and operation definitions. So far, we have distributed a Forge application per major FHIR version, so you can download a Forge app for from these two ranging to R4 right now. And Forge is designed as a Windows desktop application. It can be run on Mac or Linux via Wine, and we've got some documentation on how to get that running. But yeah, it's mainly a Windows desktop application. Links for the Mac or Linux Wine installation are found in the description of this section, or you can find them in the documentation of Forge. So Forge is free for non-commercial use if it is used for if it is used personally or for educational use. Well, this Let's Build session definitely falls under the educational use, so we can use this for now. But normally, if you want to use Forge for commercial use, it's licensed together with the simplifier price or simplifier plans. Which also comes with a lot of other additional features you can use to collaborate with other people on your profiles. So for the exercises, we've created a couple of exercises that are breaking down into 5 parts, each covering a type of profiling ranging from basic profiling and actually starting up with profiling to more advanced profiling features such as derived profiles and slicing. So during this Let's Build session, it may not be doable to cover all the exercises, but they will be available after DevDays as well, and we can answer any questions that pop up later. However, we're now here, so we can recommend you to do them now, and we can answer questions in this session or during DevDays. You may expect a fast response time. To start, I will demonstrate how to get starting with creating profiles. And how to publish a profile to simplifier, and afterwards it's all up to you. So first of all, let's start Forge for R4, which I've opened over here. And to start, Forge requires you to select a profiling folder, also a working directory.
We don't see the Forge at the moment.
Oh, thank you for interrupting. Let's see if I can. Looking. So what do you see now? If I can ask.
I see the presenter view of the I see your PowerPoint.
Oh, whoa, it's on the different side. Sorry about that. I will stop it and share my screen again. Share. So, yeah. Can you see Forge now?
Thank you, yes.
Great. So let's continue. So Forge requires a profiling folder. So on your desktop, you can create a temporary folder. I will call it, I've already created one. I normally always check this box of including subfolders. For now, it doesn't really matter, but if you have a whole working directory, it may be hard to miss. So after selecting a profiling folder, you can create a new profile by hitting this new button. So for this demonstration, yeah, we can create, for example, a blood glucose measurement. So click on new, click on research profile, and now we need to find a suitable FHIR resource that is capable of containing our blood glucose measurement. Well, this is an easy one because that will most likely fit best on an observation resource. Well, we can give it a name of our profile. So let's call it blood glucose. And this is the canonical URL that is important, as Mirjam showed in her slides as well, because this is the unique identifier of our profile. So in our exercises, we will give it our own name with our country extension, and Forge automatically adds the name of the profile at the end. So we're okay with that for now. So we can press OK. So now Forge gives a warning about that it uses the latest patch version on the FHIR version. Well, we're okay with that. Just let's continue with the latest version. So now it opens the observation resource and it instantly gives us a warning. So let's check that out. It's just complaining about that we don't use a proper name. So here at the properties tab, we can adjust all the metadata of the profile we're creating. We can see here the URL again. And Forge says that this name is not valid. So we can adjust it over here. And now that should be okay. Well, we can give it a draft version and maybe give it a title. But here on the property tab, you can alter all the metadata of the profile we're creating. But the real magic happens over here in the element tree, because here Forge renders the observation resource. with all the elements. And on the right side, if we press, for example, on our subject, it would open up the element definition. And here on the right side, we can put all our constraints or our requirements. So for example, here we want to have our glucose measurement will always need to have a subject. So we can make it mandatory. Or for our system or our implementation, we always expect that the blood glucose will have a value. So we can make it mandatory again. But we can also, for example, give it we can constrain it to only one type, for example, a quantity that will be most useful here for our glucose measurement. And well, our system doesn't need any components, so we can get rid of it, or the derived from, we won't need it as well. Just to show you how the profiling works, maybe we can have one last constraint. So for example, at the code, we can say that our codes need to be coming from Loink, for example. So with a couple of clicks, we actually produced a profile. So now we can save it and publish it to simplifier to see how it's rendered. So let's save it, give it a name. And then here, if you click on the profile, you can go to File, click on Publish to simplifier.net, and here, if you already logged into your simplifier account, when you open up Forge, you will find all the projects you have with the premium model of simplifier. That will be 1. Make sure that the project has the same FHIR version as the resource you're uploading. So I created a profiling tutorial project where we will upload this profile. So now I'm going to switch to simplifier. Get rid of this one. I'm going to go for that project, which is all at the bottom. So now I'm in the simplifier view in my project on the home tab of the project. If we go to resources and, well, let's order it by last update, descending, I see here my glucose profile I just uploaded. And it should show all the constraints I've just added. And what's good to know is that we have 3 different views. So if I click on the differential view, that will show you all the constraints you've added on top of the base profile, which in this case is just a HL7 core observation profile. And here you can see all the changes I've done. So I removed component, and we've made subject mandatory, and we put a fixed value on the system over here. With the hybrid view, you will see your changes and the snapshot, but then grayed out. And the snapshot view shows all the changes together. So from the base profile and your profile, and as you can see, it has removed the components. So we're going back to the presentation because this is the demonstration so far. Give me. Now it's up to you. So here you can find the link to the exercises. If, as Mirjam told before, it's also given as a question in the Q&A section. And it's time to open Forge and start profiling yourself. This is the website. If you click to the link, you will find here under the exercise button the 6 or actually 5 different exercises. So I suggest to start with just the first one, basic profiling, and try to create a profile yourself. So you can, if you have any questions, put them in the Q&A section, or you can also unmute yourself and just ask here in this session to us. So are there any questions so far?
No new ones that I see on the Q&A. So, oh yeah, two now. So I have a bit of a delay sometimes in the
Yeah, you need to refresh it.
Okay. So one is about the RDF representation of the FHIR model and whether Forge generates that. At the moment, we only can generate XML and JSON structures.
Well, and to be more precise, Forge always, for now, generates XML files. But if you're on simplifier, it will also automatically give you the JSON formatted view as well. But I think you would need to use other tooling to convert the XML or JSON to RDF.
And another question is about binding multiple code systems to a coded element. Well, that's of course a little bit more further on in profiling when you are going to bind anything to a coded type. I can answer already that if you have multiple code systems that you want to bind to something, actually you don't bind to a code system itself, you bind to a value set. So perhaps Ardon, you can show that just real quick.
I can show
everyone else, you can just get started with the exercise and then let us know if you have any questions there.
So let me see. Yeah, so for this example, I can perhaps open an example of a medication profile to demonstrate how this can be done. Let's see, open. I think I need to open another profiling folder. Oh, this STU3. Okay, I will just demonstrate it here. In, for example, this. Let's remove this. Here, the observation itself also has a code, which is of a type codable concept. And if you want to allow different code systems that can be used, and you want to specify those, I would suggest you slice the coding element, which I will do over here, and add 2 slices or more, as you know. So here you would have code system 1, and here you would have code system 2. And on the coding level, you can put a value set as a binding, which here you would need to have an URL to that value set, which can contain the value codes or the entire code system. You would do here exactly the same. And then the hardest part of slicing is you need to find a suitable discriminator. So the validator can discriminate between the 2 slices. You can either do this with a value set slice, value set binding slice, which is of type value, and then the path would be this. But that requires you to have the value set that you would bind unrequired. Otherwise, the validator cannot check if one instance of this coding meets this slicing definition. So as Mirjam said, it's already a bit far into the profiling material. But in the meantime, I can search for an example where we've done this. to demonstrate this a little bit better. Are there any other questions in the meantime?
Yes, so there's another question asking if we can show an example of extensions.
Yeah, we will go to that. One sec. Profile. Here. I'll zoom in a little bit. So here's I am showing an example of a medication resource where we have different value set bounded to a coding. That all those code systems specify a medication resource with a different hierarchy. So they are actually they are allowed to be used as multiple codings next to within one code because they all represent the same medication if you use multiple codings. And this is a way how you can do that, or how you can profile multiple code systems to one codable concept. If you see here, the value set itself only says include codes from this code system, or include all codes. So Mirjam, you were talking about extensions.
Yes, so the question you've just answered is by Madav, if I pronounce your name correctly. If not, I'm sorry. Did that answer your question? If you can unmute, then that would be really helpful for us as well to know whether we've answered that question about the code system. Okay, well, I don't hear anything, but if there's any follow-up to that, please ask again in the Q&A and we will see about that. So another question was, can you show an example of extensions? So that would be a really good demo, I think, as well, if you could create an extension and then add that to the observation, perhaps.
Yeah, that's a good one, Mirjam. Thank you. So yeah, let's add an extension to Blotcode. I think that's also the second exercise where you are guided to add an extension to a profile as well. So Forge needs to have access to an extension before you can add it. So if I now press on extend, Forge doesn't find anything. So there are multiple ways on getting those extensions in your profile. You can create a new one by clicking here, new, and clicking here an extension definition. Or if you want to reuse an extension from, for example, the FHIR spec, because the FHIR spec also has core extensions, or from some other project, you can download them and put them in your working directory and press refresh. Or what's also a very neat feature of Forge is you can retrieve a package and get all the extensions to your working directory instantly. So for example, let's get the HL7 core specification. So we will go to the project, to the working directory, then to the dependencies tab, click simplifier and search for HL7. That will show you all the packages with HL7 in the name on simplifier. Well, we want the core spec, so click the core, go for select the version and then add. And this will get you the entire FHIR specification to your directory. Well, if we press folders, that gives us a better view. And if we now go back to our observation profile and hit extend, we will here see all the HL7 FHIR core extensions that are allowed on the root of an observation. For this case, we can just add one, maybe one that's that works best with the Blotcode, maybe a focus code. And then we press OK. And this will add the extension to our profile. Let's give it a name, focus code. So here we have this extension added. Well, we can save it and publish it to simplifier and see how it's rendering. Yep. Need to. So here we've got the blood glucose again. Now you will see it has an extension, our focus code, with here the HL7 core extension URL. So yeah, to recap, there are multiple ways of getting extensions into your profile. You can either define them yourselves by going new, go to extension, and here you can define your own extension, which you can then add, or you can reuse other extensions, which is definitely preferred, and add them to your profile as we just shown. Hopefully this answers your question. So Mirjam, do we have any other questions?
Let me just reload again. So Madav was kind enough to put another thing in the questions, because I should have unmuted instead of asking to unmute. But the question is if you can provide the profile that you have just shown or demoed, at least if you can provide a link to that in the Q&A. So that's something that you can perhaps do afterwards.
Definitely, I will do that.
I will answer it and link you to that. So you.
I will find even a better example, because I think the example I showed was of STU3.
Okay. So I'm not seeing any other questions at this time. So hopefully you're all trying to get your first profile done. So that's the idea. We still have 5 minutes left, Ardon.
Mm-hmm.
So we will monitor the chat or the Q&A a bit more to see if anyone comes up with a question still. Can you explain slicing is a new question here. So perhaps we can still get a couple of minutes doing that, because it's an important part of profiling, but also one that you will not start out right away with. It's a little bit more complicated as a concept, I think. But
Yeah.
Ardon, you might want to detail a little bit about that, perhaps.
Yeah, I can do that. So for example, an identifier, the identifier element is an element in FHIR that you will most likely want to slice. Because if I start profiling the identifier slice here, that means that every identifier in the instance will need to look like the constraints I'm putting over here. But that might not be what you want, because in the real world, a patient can have multiple identifiers. For example, a social security number, but also an identifier for in a system. And if you want to make multiple or different requirements for identifiers, you will end up by needing to slice the element. So for example, if I would slice the identifier over here, I can put two, let's see, where am I? Sorry. 2 or more identifier slices. Maybe let's add 3. And in every one of those slices, I can make different constraints. So for example, here I'm saying there needs to be one identifier slice that contains a use of official that needs to be required, and the system needs to be well, for example, this one, and it needs to definitely have a value, otherwise I can't do anything with it. Oh, and the system, let's make it value as well. And then for another slice, I can say, okay, this can be the old or the other slices, and we put it on use old, and we can put other constraints here as well, make it mandatory. This allows the validator to check if there is at least one identifier slice with the use official, and you can check if another slice meets this criteria. So you can be more specific on your profiling requirements if you use slices than if you would just try to put everything into the base identifier. But in this case, you need to finish the slicing by giving it a discriminator to help the validator understand on which elements the slices are differentiated. In this case, we gave it a mandatory use, which has a different value for those two slices. So we can slice on the use element. So we can put a type value slice, and we can set the path to use. So the validator knows how to distinguish the different identifiers in the instance.
Yeah, so that was slicing very quickly. We have, I think, 1.5 minutes left, Ardon. So I would like to thank all of you for participating in this particular session. If there are any remaining questions, please post them in the Q&A and we will try to answer them after the session. Or you could also send us a message in the Whova app. If you require extras, we can set up another meeting as well. The FHIR team has a daily meeting around 10 a.m. I think it is. So if you want to join us there and get some more information or a demo, then please do so. Ardon, you also had an example solution, I think, to the exercises, didn't you?
Yeah, they are. So on the main page of the exercises, you will be linked to the project that contains the implementation guide with the exercises. And in that project, you will find profiles that are made for those exercises. So you can check yourself as well.
Okay, so with that, thank you for your attention, and well, hopefully see you later on again.
Yeah, thank you.
Awesome. Thank you so much for that interesting session. And Jean, thank you for being the moderator.
Yes, thank you. Thank you both as well for the hosting and co-hosting there.
Thank you. You're welcome. Thank you all for participating. Talk to you soon in another session till we meet again. Bye, everyone. This is Sadhana Alangar signing off.
Bye-bye.